We're live. We're live. I think we're done. Yes. I see it streaming. Okay, great. So hello, welcome back to the me struggling to make a game engine stream. Plan for today is gonna be pretty simple. It's gonna be the same exact thing as the last couple of weeks. We're still trying to make our architecture a lot better than the initial just everything in one file go. Today we're gonna focus on, I think, the render API. I've got a lot of improvements in mind for that. We'll jump into that pretty soon. As always, hello, welcome to the stream. How has your day been? Mine has been pretty okay. It was a hard day at work. Nothing seemed to go right. So I'm a bit tired. But I mean, I want to take my mind off things from programming at work by programming on my own game engine. It's more logical than it sounds. Yeah, we'll jump right into it in a second. Let me just get my let me see if everything is good. Let me do some just some last minute how do you call it, administrative changes, checks, and then we can get going. Yeah, I'm still trying to get my second monitor setup figured out. Laid it out a little bit different than last week. So I got my stream, I got my OBS, I got just a random tab with random stuff, and I got my talking points. So if I ever need to remind myself of what the plan is of this week's stream, got it open on my second monitor. First monitor, well, I'm sharing that in a second, so you'll see all of that. That's not changed since last week, the week before, always been the same. So, alright, just give me like a second to set up everything, and then we can start going on the game engine. As always, I'll just start off by showing what we have so far. And if you've been tuning into the streams, you'll know it's just a triangle on the screen right now, and it's been like that for 3 weeks now. So I don't think we'll change that today either. Although, if we get it working properly, if we get far enough in the changes to the render API, making it more, having a better structure, maybe we can even get 2 triangles on the screen already. That would be interesting, wouldn't it? Okay. Where do is it this one? No. Wait, hold on. This one then. Yes, okay. Well, hold on. That. Whoop. Done. Done. Okay, I think we're set up. That's about it. I think we can start going. Oh, before I get into this programming stuff, I do have a question. Well, I've been pondering in between streams, but let me just transition to this so we can see the nice triangle on the screen and everything. Great. Okay, so I've been wondering about this for quite a while now. Basically, I've been doing every single line of programming on stream so far, and I'm not sure if I should change that, if I should allow myself to actually program off stream as well. Okay, so there's pros and cons to both arguments, right? Pro of doing everything on stream is, I mean, it's all on stream, that's pretty cool to say, but it's also pretty annoying to hold off on working on it. That's one. Secondly, there's gonna be like very easy fixes I need to do in the future, and making that rule, I mean, I know at some point I'm gonna have to break it, or I'm gonna break it, and I will program at home. But the downside is allowing me to program off stream is there might be some buildup of expectation over the time that you see bigger changes. You see, you would leave my stream at the end of one day, come back the next week, and you would expect a significant change to be made. And I can't guarantee that at all. I don't think it will ever happen, especially not in the beginning. So I'm weighing my options there. I think I won't give a ruling on it now. That's why I've been holding off on actually programming off stream. but we'll see what it says. But I mean, I ran into this issue because I was thinking about last week and what we did. And last week, if we take a look at it, we can stop this now. We can actually go into programming. We made like our build system a bit cleaner, and then we did this whole compile option and link option thing, and I thought of a better way of doing it. Well, actually, I think it was already suggested during the stream as well, but I didn't think it would work, or I didn't want to use a specific way, but it's much cleaner to do so, especially now that we have these lists and we have to concatenate the compile options and the link options together in one list, and it's not that great. It's definitely not that great. So what I am gonna do instead for those things is, if you go to here, we don't have this list append anymore. We can just make I have it open. Wait, hold on. Let's find it. There we go. I have add compile option. So we're gonna do just add compile options. And what that's gonna allow us to do, so we don't need to do it for each config. Well, we're gonna start with for each config, but I don't think we need to. And now we just do add compile option. I think it's just the option itself, right? But we're gonna use generator expression so that we can do this. So we're gonna do that, then that, and that. And same with add linker option. You can also just do add linker option, then I think it is. It's on the bottom here, I think. Add link option. So not compile option, but link option. And what that's gonna allow us to do is, once we save this, right, we will be able to get rid of these things. We don't need to set that anymore. I don't think we need to set these either. So that will be helpful. Same with the link flags, we don't need this. So that makes it a lot cleaner. That's all nice and clean. I do think we don't need this anymore either, so we can leave it off. Although I might just put it there because I'm manually setting them, so we'll leave that. And then hopefully if we do rebuild solution, we should get the same exact things. Oh, Visual Studio X. There's 1-0 there. The 1-0 doesn't make sense. Oh, maybe we need to. Oh, I thought that was it, but maybe because I know we can do. Oh, that's just clicking the link. We can use this. It specifically says we can use generator expression. So, oh, maybe we need to wrap it again. No, that makes no sense. So we do have this generator expression in here now, but maybe it's an if. There's like an if, right? Maybe that's what I need. There's like a conditional if condition true. Maybe that's the one. Maybe. Typically, condition is itself is a generated special variable, so it's a following expression grants debug mode when debug conversion is used and add this string for all the others. So this is what we need to do. So we need to do. Oh, we just need to wrap it in another. Okay, I get it. So we need to do. Is it this? Maybe. So config debug and then this. And that should work. And then same for this part. And then hopefully that works. I didn't want to spend too much time on this. Because I do want to get on to actually programming today and not just working on CMake. Why is it? No! Ah. I messed something up. That's what it said, right? Config. And what's putting it in there? Don't see it yet. Oh, it's doing this. But do I not need that? Oh. Oh. We need condition exclamation. Does that work? Slow start, I guess. Oh, that seemed to have worked. Still works. Okay. There's one easy way to test this, and that is by putting like an. Do we have like a? We can do like Windows show 1, and then let's make this function. Make it for instance int a as well, and then this one also int a. There we go. And if we compile this, it's not what I wanted. Rebuild solution. It should complain. Okay, so it does work. Save that and revert that, and then in the main file as well. Okay, done. Okay, we got our CMake set up, we got it figured out. Although, there is one other option we could do. But see, this is the thing I could like mess with off stream, right? Because what we also could do, what I also know, is that there's like a configs thing, so we can technically put the full list in here. So we actually don't need this anymore. We can just do arg in. Oops. That's me failing between that again. And then we can get rid of the for each as well. Right? There we go. And that might work. I'm not sure. We'll try this. If it doesn't work, we'll just leave it and maybe come back. Okay, so yeah. See, that's what yeah. Okay, so we're just gonna leave it at the for each loop. I think it's fine for now. It's not like we do that big of a well, we don't do that big of a build anyway so far. So rebuild solution, that's our state. Oh, I messed something up. Did I forget something? Did I? Oh, no. That seems correct, so rebuild solution. Hey, now you're working a second ago. There we go. Okay, it's working again. Might have not just had something wrong. Okay, so I think that's all fine. So today we're going to be focusing on listing, the render API. And maybe we can, if we have time left, but I don't think so, we can start working on the base application class as well. So basically we want to make this into an interface that we can use for different types of renders. Right now we're using DirectX, but if I ever want to switch to Vulkan, if I ever want to compile on Linux, on Mac, I'll need to use Metal, stuff like that. I need to be able to swap them out like instantly without changing too much stuff. And mostly how we do that is we make an implementation and we have an interface. And the interface, well, that was a bad way to explain it. Let me start again. So basically you make an interface that will just say, this is all the things you can do with it. It's generalized, it's unique, it's obfuscated, there's no specific library implementations in there. And then we have the implementation file, which implements those functions for a specific library. How we're gonna do that, I am not exactly 100% sure yet, because I also want to do it, I want it reflected in a build system as well. Again, that link is gonna be horrible. But what I do want to do is start by making a generic API, and then making a render API specifically for DirectX 12. So today we're gonna implement things twice. Once in the interface, which will just be a bunch of empty function calls, and then once in the API. But that also means that we're gonna have, not only for a render API, we're gonna have to have generic classes, but for all the render concepts, we're also gonna have those interfaces. Like the Render target, basically the screen we draw to, that will be one. GPU resources will need to be generalized as well. GPU synchronization will also need to be generalized as well. I'm not sure if you're gonna just make a fence and a barrier. I'm not sure how Metal programs it or how Vulkan does it, but we are gonna work with DirectX first. If that bites me back in the ass later on down the line, who cares? But I do want to make that concept already so we have the least amount of troubles if we add another rendering pipeline. Does that make sense? Also, this will also need to hide Windows because DirectX is specifically for Windows, so it uses window handles, it uses hresult, which is a Windows thing as well. We gotta work it out first. So, how am I gonna do this? We need to think about this properly. So, we are gonna have our API. I'm gonna put that into render API. But then, basically, we need some kind of file of build configuration that decides which library to use. I was thinking, well, I'm not 100% sure how to do it exactly, right? Let me actually look up the concept. There's a concept called Pimple, right? C++, it's just a pointer implementation. So basically that means we have a class which has an implementation, but that implementation is a pimple, so it's a pointer to something. And basically what that does is our interface will just pipe everything straight into the implementation. But there are some downsides to this. So this is an example. So we got a class widget with an implementation, which is inside there, right? This is in the header file. And then in the CPP file, we actually have the implementation. That's one way of doing it. I do like that approach, but the only overhead is basically what we do here is that's the class, but then for the widget draw, we just call it. For the draw, we call it. For this, we also call it. For that, we also call it, right? So that's it's not that great to it's not that great to go about it. So what I will do, what I think I will do at least, is I'm gonna be hacking a bit with header files and CPP files. So what I'm gonna do is I'm gonna make the interface just a header file. And then based on the library we're gonna use, I'm gonna include the implemented CPP file. Right? So actually, let's set like a basic text file in here that we're called to do, and then we can work on that. And basically, if we have needs to put anything in some kind of, well, if we need to type anything out, right? So we're gonna have like a to-do scratchpad. Let's call it scratchpad. Scratchpad. I can't type. Scratchpad. It's in there. Is it typed correctly? I don't think so. Do I care? Scratch. I think there should be another H and a C in there, right? Yeah, that looks more correct. Either way, we got it in there. We're gonna have to add it to this thing because I want it in here. So this is gonna be stupid, but we're also gonna, inside here, we're just gonna add a file. That's stupid to do though. No, I don't think so. We're just gonna yoink it in there and then also pin it. Where's the pin? Pin tab. There we go. And pin it as the first one. There we go. Okay. So what we're gonna do is basically in our render API, we're gonna make, it's gonna be stupid with render API .h, and then we'll have an implementation folder, or like a let's call it like DX12 folder. Inside here we're gonna have a render API.cpp, and what we're gonna do in the cmake list file is include this depending on whatever we want to do. I think that's a good way to go about it. So that basically, again, if you need something else like a render target .h or a material .h, all gonna be render API concepts, we're gonna have to implement them for DirectX. So what we're gonna do is just render target .h and material .h. The hard part is this is gonna have to be universal, so library independent. Library independent, right? And this is library specific. So all the things we put in here will need to be universal. We'll need to work with every single library we make. Might not be the best way. So then basically if we eventually add metal, we'll just put a metal one in here, and then we're gonna copy the same thing here, right? And because I think, well, it's fine. Because I think we're can conflict between this, what I'm gonna do is I'm gonna prefix these. That's not a prefix. DX12, like that. And this is just so we can easily find them back in, well, basically in if we need them. Because we can technically include all of them in the project, but this basically, if we work with on DirectX, we'll specify that folder. If we work with Metal, we'll specify this folder, right? And it should work. So I want to test that out and see if we can switch between the two. And if that works, then we're gonna start implementing it. I think that sounds great. Lovely folder. Okay. So this, we need to do this. I am considering making maybe a separate module for each, but I don't want to do that actually. I think it's better if we just put it all in the render API. So we're gonna do that. So first thing we're gonna do is split it up on disk. So on disk, what do we have? We have our engine, we have our render API, and right now we have this. So we're gonna make a new folder called DirectX12, like that, and we're gonna put hue inline file as well. I'm gonna put all of you. Oh, DirectX pointer is just a unique concept for DirectX, so we're gonna put all of those in here, right? Perfectly fine. Interesting. Why do I have a thing imaging over here? Either way, we'll be fine. What is this? Okay, nothing to worry about. Okay, so we got a window and a render API already, and then in here we got our application or implementation. We need to rename these, so let's do that as well. DirectX12 underscore. Let's copy that so we can do it easier. Then same here, but I'm gonna get rid of the DirectX API and just call it like that. And then same in here. Good, I think that's nice. And that makes sense, to me at least. And these, I mean, they're specifically for render API unique pointers, so we might have to like call them differently or make them like a safe render resource thingy. I mean, basically we're gonna fix this with the whole API thing, so maybe we can get rid of those. Either way, that's it. So now we're also gonna have to change the CMake file, which I think we can do in here. So I don't actually need you anymore, so you can go. Compile and link options I also don't need. Application, no, not at the moment. Render API, this is the one I need. So basically what we need to do, let's make this pinned and homebrew as well, because I'm gonna need this. We're gonna set up the environment. So we're gonna do environment here, and this is basically gonna specify what we're gonna do. So we're gonna define set render pipeline. No, we're gonna just set platform, HP platform, to win 32. I think that makes sense. Or actually, let's define our platforms. So, do we make like a separate file for the environment? Maybe. I mean, I didn't want to do CMake stuff today. Oh, where's my... Wait, hold on, not that. There we go, okay. Do I make a separate file? Probably. It's probably best, isn't it? So... Actually, we're gonna do it in here. So this is gonna be our possible environments. Possible platforms. And it's gonna be... Copy this to... Win. And that's the only one we have at the minute, right? But we can eventually do like, what's it called? OS X, or let's call it Mac, right? And then we can do that to Mac OS. Stuff like that, right? We can do that. And then we can set our platform to the value of this, which will be, if I remember how to do CMake, this. No, not that one. This. Right? And we're gonna call this current platform. So the possible configurations we might set up somewhere else, right? Because we already have this as well. So you might want to do that in here. And then we're gonna set up the environment here. That makes more sense. Current platform. There we go. So we got our current platform. Then inside our render API, we're gonna set headers to all of our headers. So we're gonna put this one in there, this one as well. I did something. Oh, I changed my keyboard. What the hell? Uh-oh. Oh, it's still the same one. Oh, great. That was absolutely useless. Great. Okay, we got this. So that's all the headers we have. This one is specifically for API, for our API. And then if platform is Windows, how do we specify that? Can we just do if checks on setting? I'm just gonna do, no, what is HP platform equals equal to, and then we're gonna call HP platform Windows. Then we're gonna set some more sources, and if, oops. And then the sources are no longer called this, but they're called DX12 underscore, and then the other ones. So this basically means we're gonna do that. And then we're gonna do sources. So we're gonna do headers sources, right? Can I do that? Does add library allow that? That's not the wrong, that's the wrong one. I just need to look at add library again, because I don't know if we can do just full sources. So sources, I think we can do that. Yeah. Alright, so that's perfectly fine. So then we can do that. We'll do that. The link libraries also is something we'll need to pimple out. Well, basically we want to only link with all of these things when we do the platform, right? So that's the messy part. I'm not sure if what is that messy. I mean, we could also make it a bit hacky and say that we want this this prefix, but then again we still need these. So we're gonna also put a set libraries, additional links, additional libraries, or link libs to all of these. Yoink. And then we're gonna put link libs in here. Basically like that. I think that's fine. I think that's perfectly okay. Right, because we can do everything we want with this. This is, let's call it, yeah, no, that's fine. I think that's fine for now. This should still compile, but it will give us problems, compiling options, but the CMake should run fine now. If I did everything, oh no, wait, no, it's not correct yet. We need to specify DX12 here. And I think we're also gonna need an additional include lib. But I think this one does it. Oh well, we'll see. So this is probably, oh what, okay. Advanced build actions. Why can't I rebuild solution? Stop. Stop. Okay, it's breaking. Great. Stop it. Stop. Stop doing things. Oh wow. It's stuck. It's stuck, people. Oh, great. I think that's all fine. Right, I think so. So I like this. I'm not 100% sold on this. Yeah. But it does give us like a chance. Are you still doing... what the hell are you doing? Let me just cancel that. You're trying to open a file that doesn't exist. Oh, Jesus. Okay, let me just restart it really quickly. Did you try turning it off and on again? It's the easiest easiest solution. It's always the easiest solution. Okay, so that one. Okay, it opened it in the right tab. I think you can see it again. Great. So we need to rebuild. So let's try that. Advanced build action, rebuild solution. Another build already in progress. Oh, you have to build it. Okay. Rebuild solution. Can I do it now? Great. Okay. It will give us problem. Cannot determine linker language for target render API. Ha! Interesting. So I think that means... oh, probably because this is that. Yeah, so we need to combine sources and headers and sources. So can we just do list append? List append. That should work. And then I know sources is a bit weird in that context, but that should maybe work. I don't like CMake. Oh, still not. Is it not list append? Might not be list append. CMake. List append, list elements. No, that's correct. Okay, so... oh, I know how to do it. Where is it? It's not that. It's set sources. Sources to... and then we expand sources again. And then that should work. Probably, hopefully. Rebuild solution. No. Nope, still not. Okay, so message time. Message sources. And rebuild. That should give us a list now. It didn't. It didn't? Huh? What if we... Oh, it's in the ifdef. Oops. So I think that's already the issue right there. The ifdef doesn't work. And we only have headers in here, right? So it doesn't work. I think that's the issue. So let's leave that there, but let's see what's the... It's string equal, isn't it? Equal. Build solution. Oh, that is better. Yes, okay, it was that issue. So this string equal. So I want to make an isPlatform function. So how do we easily do that? Can we return a function? CMake function with a return? Can we do... Oh, we can do if, and then that should result into a... We can do return and then this, right? Yeah. So we can make another helper function. I really didn't want to do CMake today, I swear. Okay, so I think we need to open this file again. Where is it? Homebrew, CMake helpers. Then we're gonna add another one. This one is gonna be a function, I think. And it's gonna be called isPlatform. And it's gonna take an argument which is called plat. And then we're gonna do end function. And we're gonna return if, and then we need to condition again. So we can just yoink this, put it in here, and that should be this. I think. Right? Or maybe... I think this is correct. We're not sure. Not 100% sure. We'll see. And then inside render API, we can do if isPlatform. And then we're gonna do HP platform. Windows. There we go. And then we can set sources here. Will that work? Maybe. Possibly not. I was hoping this would work. Okay. Let's try with a macro. Let's do a macro. This gotta be stupid if it works. Or we can just do this and then end macro. It's also not gonna work, is it? Nope. Let's try and find a function that returns a bool. Would only propagate, okay. Multiscope. Propagate that. Return bool. Don't think it's possible. Okay, so then let's just leave it as it is for now. So no helper here. I don't want to spend my time on this. And then let's do that. String equal Windows. I'm gonna leave a note saying improve. There we go. And we'll fix it later. That's how it works. Okay, this all works. And then we just need to also put the include targeting libraries. We did like, I still have the helper open, right? We did directly include directories. We need another one. Which is gonna be annoying. So we're gonna have to do project name. Nah, it's... Yeah, and then include. There's... Okay. Oh, that's the executable. Yoink. This one. Add library, include tiers, and then also... I need to expand it, right? Twice even. Include tiers. There we go. And then we can also add include tiers to this. So sources, and then we're gonna do include tiers, and then we're gonna set include tiers in here as well. To what do we set it to? I think if we go back here and we just put this. Do we want that? Actually, is that fine? Yeah, I think that's actually fine. Now we need to... Okay, never mind. We don't need this. I'm changing my mind left and right here. Okay. So we don't need any of this. Okay. Rebuild last time. See if everything works. And then if everything works, we can start compilation. Yeah. So this doesn't work. I knew this wasn't gonna work. This needs to be DX12 slash, oops. 12 slash this one. There we go. Fixed, right? That's all of this. And then in here, okay. Oh, that's gonna be a bit annoying, but we can do DX12 render API. We include this, and then this is gonna be DX12 / unique pointer. There we go. DirectX should still be in there, because it should be in third party. So wait, we don't have a third party include path yet? Oh. How did we find this before? Interesting. Because we have add subdirectory here. And that one has a, oh, that's too far. See, make lists. I shouldn't have opened it. Oh, okay, yeah, okay, this one is just wrong. Because it shouldn't do this. No, wait, that's correct. So, wait. Let's rebuild it first. Okay, so this should be x12, that, and then this. Put the inline file, please. This one I can do that. We can already fix this one. There we go. The header file. Actually programming for once. Build solution. Yeah, so this one I'm not 100% sure. This should work. What are the include bots? So we got everything. We got visual leak detector. Why do I have visual leak detector? Oh, that's interesting. We could maybe even have visual leak detector. We got homebrew. We're missing an include path. Oh, the link libraries is not working. Oh. Wait a minute. I thought set link libs, target link library is this. Yo, let's just good measure, right? Dot solution. Okay, it still doesn't find this one, which is interesting because it did find it now. Very interesting. Very weird as well. So this is set up fine. It's wrong, but fine. This one. Oh, I was an idiot. Yeah, no, never mind. I'm an idiot. We need to do this, but we need to expand this, of course. That's gonna work better. Set link libs to this, oops, to you, there we go. And then let's do a rebuild. Now it should work. Great, okay. So we got all that figured out. We got our render API.h, which is great, right? All the header files, it's perfectly fine. It's just these ones that are a bit weird, but it's correct. Correct enough. Basically, I want these actually also to be like render API slash, but we're not gonna worry about that for now. Yeah, so I think we can actually start on it now. First thing we need to do is we need to throw all of this stuff out here and just make this like the interface, right? All of this stuff we can't have, which is gonna be challenging because we'll need to hide all of this. So we're gonna need to make classes for all of these things and then have them represented as well. Oh, that's gonna be an issue, isn't it? Oh, I didn't think about that. We are gonna have to do inheritance anyway. I think it's fine if you do it this way. Maybe. The issue is with the way I've set it up now, we can't have any members that are not generalized. So, how do we fix that? Do we fix it? That's also a good question. Because we could do just like for all of these, just this. And then, since this is the main class that we need to implement, we won't allow... That actually makes sense. So, let's go back to our Scratchpad for a second. So basically, this is going to be like the main entry point for a render API. Right, this one. This can only have members that's generic, right? But all of these should be able to get their own specific members. So what we're gonna have is actually we're gonna have, this is wrong by the way, it's CPP and CPP, right? So we got, let's just get our setup correctly here. Going that, copy this, post it here, and then we're gonna have a metal one for all of these. So basically that's how we're gonna set it up now. But then all of these, we're gonna make these interfaces. Abstract interfaces. Maybe abstract interfaces. Yeah, abstract interfaces. No, maybe not. Interfaces, at least interfaces. Right? And then this one will have a DirectX 12 header as well, which will implement the interface. Right? I think that makes most sense. And that way we have one generic entry point. This one can only have, this is the condition. We're gonna put that in a command in the file as well. This can't have any non-generic members. All the other things will just be interfaces, so we can expand the classes later on. But since it's the render API that decides everything, it's the render API that will make it. So we're gonna have request to the render API, hey, render API, make a render target for me. And that way we'll have whatever we need, right? And that one will make the correct implemented, overloaded, inherited, that's the word I was looking for, inherited class of what we need. I think that makes sense. So we're gonna set it up this way. So what do we have now? We have this already, render API. So now for each thing in render API, we need to make a file. So we're gonna have to group it. So let's do a little bit of management. Okay, so basically these things we're not gonna worry about for now. These are generic rendering concepts. Issues for later. Render API, we got this, we're gonna do that as well. I do want to put this in like a corelib file already, but do I make corelib? Oh, I want to do so much, it's annoying. Okay, so initialize, we can't have a window handle in here, right? So what we're gonna have to pass is a render, HP render window. So we're gonna call that, we're gonna ruin our code basically now. So we're gonna have to, actually, the window handle, that's the issue, right? Do we make it so a window can only, well, a render API can only have one window? I think at the moment that's fine. So we're gonna make sure that once we initialize it, we're gonna initialize it with a window instead of a width and a height and a window handle. We're just gonna give it a window. Right, so all of these we're gonna get rid of, and we're gonna make it a window. Up, window. By reference, by the way, window. Okay, that's that. Throw if failed, not gonna worry about it. I don't think we need that one in here. That will be in our other render API. Don't need to worry about it. I could not make this a member function, that would make sense. So then, this perfectly fine, although I would like to get rid of this. This is our window, so we're going to replace this with window. So let's do that again. Window, reference, in window. We might want to make this a pointer at some point, or actually, no, the window is separate from the render API. The render API will draw to the window, so it's separate concepts. So we'll just take a reference to it. Might even need to be a pointer, but we'll worry about that later. And this will all turn into the window. So we can comment this, that will turn all into the window. Now the tricky stuff comes. I'm not familiar enough with graphics programming to fix all of this. So we're just gonna have to hope and pray I do it correctly. These things, no idea. I think this should be part of the swap chain. Maybe. I don't know what we need this for. So it's gonna be interesting. The device, the swap chain, and the render targets. It's gonna be interesting as well. Oh, it's gonna be So I think these will all be a separate one. Then the command list, this will just be command lists. HB or command Q. Let's call it like a render command list. Render command list. Right, that's that. Area command list and RCL. Makes sense. That makes sense. To me at least. And that's all of this. For now at least. These, I'm even less sure what they should be. Oh boy. Oh, it's gonna be so interesting. And then resources, they should technically not be in here. Vertex buffer view, I don't even know. This is a triangle basically, right? This is a fence object. We can just hide this into a fence. I think this is gonna be an HB render fence. Fence. I don't know if we'll need more, but this is gonna be that one. Right? This, I am not sure. But we can start with this already, right? Get rid of some of it. So we're gonna start with the... It's not gonna be a render window though. It's just gonna be HB window. Because the window is technically not render API. I do make it in the render API, so I'm gonna keep it in the, I'm gonna say a window is a rendering concept. That might be a horrible mistake. That's the way I'm doing it. Okay, so this is gonna have a window handle. So this is gonna have to be an interface. The width and the height we can already store in there, and it's gonna say it will always have that. But the rest is it's gonna have to be that. Now, interestingly enough, we're gonna have to pass the window handle to whatever it was that we need to initialize. I forgot. Do we need to initialize with the window handle? Yeah, where is it? Where do we need it? It's not gonna say, is it here? We need it for the swap chain. I need to set up something here as well. So that's gonna be interesting. Because we're gonna have to know that, so DirectX is specifically for Windows, right? So we're gonna have to upcast it, make sure that it's the correct interface that we have. Oh, it can't be a reference, can it? It's an interface, it needs to be a pointer. Oh, it needs to be a pointer. Pointer. Hello, welcome to the stream. Making a game engine. I would show you what we have so far, which is not much. It's basically just a triangle on the screen, but I'm breaking everything. On purpose. I'm refactoring the render API to hide that it's DirectX. And struggling with it, as always. Okay. Look at all the red. Yeah, that makes sense. We just destroyed all of these things. Okay, so let's start by making the window. I think that makes most sense. So let's hide these things for now. Let's not get rid of all of our code just yet. We know we're gonna do it. Okay, so add that. You don't need a breakpoint there. Okay, so we didn't destroy this so much. We do have a pointer here that we need to worry about. And then this should actually be all okay, but we're gonna do initialize with, we can actually initialize with a HP render window reference window, and then we're gonna set window to the address of window. That's very dangerous. We're not gonna worry about it. The width and the height, I am not sure if you want to get that specifically from the window every single time, but I do think we need to. Because we're gonna update it on the window, but that means we're also gonna have to update the render API. So there's two things we could do here. We could say that the render API keeps track of the width and the height. I don't want to do that. So every single time we're gonna have to do width and height, we're just gonna do const float width. I can't type width. This happens when you do CMake for the whole time. You forget how to type, and then we're gonna do window dot get height width, right, like this. Okay. Now, still a bunch of red. Actually, we want to get rid of that, and we just want to make an internal function basically that says private, and then we're gonna do float get width, and it's gonna return. Actually, I can do that in here. No, I can't, because then I need to, width height. There we go. And then we're gonna copy that in this one. It's just gonna be get width here. And same for the height. It's just gonna be get height. We don't need this anymore. The window is still initialized. Needs to happen first, but that's fine. And then we got width and height as floats, so we don't need to cast these. Wait. Oh. Okay, you win. No, they need to be floats. I want them to float, and then we don't need to cast these. But we need to cast the other ones. Width in here, we need to cast to whatever it is. I think it's just an int. Right? What is this? Type def rect. Great. What is a rect? Along. Okay, so we need to cast it to along, which is along. Okay, great. That makes sense. To long. There we go. And then same here. Height to along. Oops. There we go. And then can we cast floats to? Yeah. So that's gonna be width and height here as well. Window handle. This is gonna be an issue one. This is gonna be a tricky one. So we need to upcast the window to whatever it is. Oh, it's gonna be annoying. Along is along, yeah. Figure that one out. Oh, glass is empty. So I don't want to get too technical with the abstractions, right? I still want my render API to be something useful, but this is gonna be tricky. So we need to upcast the window basically, because window the get handle, we can't do that. Well, we can do it here, right? But we can't, because basically what is... Oh, I already have it. Yeah, we return a window handle here, which is, if I remember correctly, it's, well, it is just an int behind the scenes, but honestly, we can't assume that. So we'll need to upcast it and only make sure that the function is on there. That's why it's a pointer, right? So we need to make sure it's dynamically casted here, maybe? Oh, it's also not the greatest. Well, we could just... No, get handle needs to return a H window, so we need to... I don't want to do that. How do we get around this? I mean, we could just get around it by saying get handle returns something and then cast it to... But that's also gonna be stupid because we're gonna cast it to something else, like an int, then cast it back to a window handle. So this is gonna be tricky to do, which is what I was worried about. Which is why the render API could also just be an interface. And then we have all the members on there. I mean, it seems like we're gonna have to do that, isn't it? So basically, if we go back, the issue I'm running into is the same issue I had with these, is that we need members that are specifically the implemented types. Just do that and run it? No. This is a long-term project, so we need to think about the small things as well, unfortunately. So basically, I did only have like a render API CPP here and no header, but it does seem like I'm gonna have to do this. And then we don't have this, it should also be an interface. I think that might be the way forward. Oh, that's a bit sucky because then we have this and that. But that makes kind of sense. But then the issue is we'll need to invoke it, which I didn't want to do. See, the good thing about not having this file is we can just create a generic render API because this one will be generic as well. But now, because we're gonna have to do an inheritance-based structure, we will need to make sure that the pointer we create is the DX12 one, and I wanted to hide that from the rest of the application. I only wanted to do that in a build system, which is annoying because everything else should be abstracted. It's just this one single file. Can I do that? I mean, I can just do a get window handle. Could I get around it somehow? I mean, I can just upcast it. Let's just upcast it. Okay, let's, so I want to do what I said before. I want to keep it this way, and it might be a bit slow, but it's only on initialization, so I think it's fine. So for this, we are gonna do get handle, but we can't do it on the M window. We need to do it on the... Oh, it's gonna be dynamic casting. That's annoying. Do we need the window handle anymore? We do here. And do we need the window handle more? No, that's the window width and height. So I think that's all fine. Actually, hold on. Hold. Hold. So, we could get around it actually, because we don't need it. We need to make a swap chain, which will be a separate... Oh wait, how did I got rid of it? This will be a separate API, so this will be just its own file, so we can pass the window here and cast it there. And that makes more sense. Because that one will have a specific implementation, so we can say that it needs to be a specific window type. We can say that in the constructor. Hello, welcome. You're new? Well, welcome. We're making a game engine. And I'm breaking everything. I do read chat. Okay, so since you're all joining, let's just make it compile first. Oh shoot. Let's focus on. Okay, so let's get rid of this, and then we worry about that when we create a swap chain. So we're gonna just do get handle here for the minute. Also fix this to do get width and get height. Width here, get height here. There we go. And then I think we just need to say fix this one handle as well. Boom, there we go. That's this one fixed. That's render API fixed. I think we still have some other issues. Mainly because I changed the initialization, so initialize doesn't take. Yeah, that's what I expected. It takes a window, so let's just pass it to window. Save it here. And then we still need to implement the get width and the height, I think, right? Yes. So hue, get width and get height, yeah, we still need to implement hue. So let's put them at the bottom. Make a game engine, but in C? Well, that's kind of what I'm doing. I'm making it in C++ because we have classes and it's a little bit easier to work with. C is a bit harder to do everything in. So I commend you for it. If you're gonna stick to it, it's gonna be it's hard. Render API. I don't want to wait for the no. I need to put the shortcuts on my mouse. Width. Okay, and this is just gonna be return window don't get width. No, get. Oh, we don't have a get width on the window yet. Oh, great. So we need to implement that first. Okay, window. Where's window? I don't have window. Window. You wait. Where's the sources here? Ah, it's in here. Okay, makes sense. So get width. I don't know where to start. Any tips? I'm thinking of using OpenGL. Good choice. OpenGL, really good, has really good documentation to start with. I'm making it myself hard and starting with DX12. Don't be like me. Really, I beg you don't be. Okay, so wait, we don't keep track of them yet. Okay, so we're gonna do int. No, let's custom to float once with window width and oops. Window height. So OpenGL is a good place to start. I would suggest making a 2D engine first, since it's a lot easier to reason about all the concepts when you only have to think in 2 dimensions. And if you got all of the concepts down, you know how to make like your input manager, how to make your gameplay work, how to draw things to your screen. If you all can do that in 2D, it's quite trivial to make it to 3D. What's the difference between OpenGL and DirectX12? Well, first of all, DirectX12 is a lot harder to work with. It does mean you'll have a lot more control over what is happening. But to start out, I would suggest OpenGL. It's a lot more beginner friendly. It helps you a lot. It basically holds your hand a little bit more. So what that means is setting things up a lot easier. So for me, I have to basically write 500-600 lines of code for just get one triangle on the screen, which is where we are right now. With OpenGL, it's probably only like 100 lines of code, and it has a full step-by-step tutorial on how to do it. Explains everything really nicely, how you do like projection matrices, how you do the shaders, how you do I mean, everything is explained. So basically, OpenGL is more like a wrapper, a safety wrapper, safety blanket around DirectX, but also other libraries. I think OpenGL, but I don't quote me on that. I think OpenGL works for different platforms as well. So if you eventually want to compile on both Windows and Mac or Linux or whatever, it will inherently work. Whereas for me, this is purely specifically Windows, which is, I mean, it's a choice. Okay, so we got the width and height set up. We just need to fix it in the constructor as well so that we set our width and our height. So we're gonna set width to that's not what I did. Window width. What? This one? Oh, it's a different button. Yeah, Godot is perfectly fine for programming stuff. But if you want to make a game engine, yes, just try and make a 2D engine. It's the way I started. It's a good way to learn all the concepts. And then once you've done that, you can maybe go and look into 3D graphics. I mean, the 2D engine, it can be a really great start to expand to 3D as well, but it will at least tell you if you actually want to do it or not. Wait, that was weird. It almost did it correctly. Okay, that's correct. With height, yeah. Open source it. That's a decent plan for it. That's how Godot works. And also, if you have any issues, it's open source, so other people can help you with it. Get width. There we go. Oh, why is that void? It should be float. And also it should be const. I'm pressing all the wrong buttons on my keyboard. Okay, so this should be const. And this one should also be const. But yeah, I do like making a game engine. One other tip I have for you is don't make anything you don't need. So don't overthink anything to start, right? Just start like, hey, I need to set up a window. So you create a window and you're thinking like, I want to draw like a character on the screen. So you want image rendering. So you implement image rendering. And then you think, I need to move that character now. So then you make like your input handler. So you do it step by step and build it up, but do it as you're actually building a game as well. That will first mean you don't do anything you don't need. And secondly, you'll also see the progress as you're building it. So that will give you a great motivation rather than just having a kind of a black box that you need to finish completely before starting the game. So I think that's a better way to go about it. That's also how I'm gonna approach it in the end. Once my rendering is set up, I will make input work. I will make like things move on the screen. Once that's set up, I might move on to 3. No, I think I already will have done 3D. Basically, I'm also gonna take it step by steps. I didn't work out the steps yet, but that's how I plan it. Also, a really interesting one is it's very easy to set up integration with Steam, and you can do that. I think as long as you do it in a development area, you don't actually need to do like the whole Steam integration, pay the fee to launch the game. But you can already know how to work with a different API and maybe even like add an achievement for your game. Increasing my programming skills? Oh, definitely. Making a game engine will help with that a lot. And also, if you start with your 2D engine, which is a lot simpler, by the time you're gonna start your 3D engine, you're gonna think about like, hey, I did this in my 2D engine that actually didn't work out so well. Maybe I'll try it a different way. Or basically, you know a lot of ways to improve it, which is also great. Okay, where was I though? How's my engine going? Okay, so we got width and height set up. I think that was all that was needed. We just need to fix the main file. Oh, we did it. Alright, okay, I think it should compile now. .solution. Yeah, it compiles. If we run it, we should hopefully still get a triangle on the screen. Yes, we did. Okay, so I there we go. Triangle. Boom. Game engine. Yeah, triangle. So we got this set up. We got it a little bit abstracted now, but now it's time to actually implement this window class in a DX12 way, but hide all of this, right? We don't want this in our header file, because this means we're using a library. and we don't want to hide, we basically want to hide that from all the rest of our code. This still needs to be the same, so we'll need to move some shenanigans. We all need to do some shenanigans here with the get handle, as I discussed before. So yeah, we're gonna have to create some more files. I do see, Kiri, you have another question. Why am I making a game engine? Very good question. Because so basically, I had the goal of making a full game from scratch, all on my own, without external help, without as little as libraries as I can get away with, which means the only library I have now is the rendering library and the Windows API, and I can't really get rid of those easily. I mean, I could technically, but it's very hard. So those are the two libraries I'm allowing myself to have at the minute. Other than that, why do I want to make it? I mean, it's just interesting to know, like, I'm playing games all the time, and it's interesting to know how they're actually made and how they function. I do have a bachelor's degree in game development, so that helps as well. But yeah, it's just been a dream of me of making my full game from scratch. That includes, like, programming, assets, so all the models you see in game, all the sounds you see in game, all the voice acting you see in game, all the sound you see, basically the whole package, the full game from scratch. That sounds like super interesting and super cool to me, if you can say like, hey, I did this all on my own. I also do have some kind of concept for a game, so I do want to, I'm more focused on like making a story-driven game, because I feel that the game development space is kind of more like an art form. So I mean, I basically want to share, well, for me it's basically creating like some kind of art piece, right? It's basically that, and sharing it with the world, making it interactive. That's the interesting part. A game is basically just an interactive painting, which is pretty cool. And having made one, like saying you've made one yourself completely from scratch, sounds insane. You love playing games as well. Yeah, I mean, who doesn't, right? And your laptop is pretty weak. I mean, it's I'm doing all of this on a not so great laptop, so it's okay. You don't need that much for the modern games. Yes, you do. Unfortunately, they make it harder and harder to do things with low spec PCs, but I mean, what can you do about it, right? I also played the more older games, like, I mean, I've played Minecraft for ages. That thing runs like a beauty on my PC, and it's not that great. So it's there's more than enough games out there that you can play, and yeah, they might not be the newest one, but hey, you got something to look out for if you ever buy a new PC, right? I do love story games as well. That's basically mainly the whole reason I got into this, was because of how should we call it? I think Life is Strange, basically. It's one game I played, and it just stuck with me, and the things they could do with that game. So that's one of the main ones I played, and that's one of my favorite games of all time. But then I grew up playing games. I played a lot of Pokemon over the years. I played a lot of Minecraft over the years. I got a little bit into competitive, like Rocket League, but well, competitive is a big word, but I liked playing that one as well. I'm not really into like the first-person shooter kind of games. I think those are not that bad. Also, recently played Baldur's Gate. Really good one. Okay, where was I? I need to make a file. Which file? The DX12 file. Okay, so we need to make 2 files on disk. We need to go to Homebrew. I'm gonna have to go to Engine, Replication. I have not played Detroit Become Human, no. Unfortunately not. Okay, so we got the window here already, but we're also gonna have to make a DirectX window .h. Right. Yes, I want this. And then inside our render API CMake list, I also need to add that one in here. Okay, there we go. I think that's all we need to set up. And then we need to rebuild, because we always have to rebuild. There is like zero check, right? And I should actually just zero check everything. So if I build this, it should add the file, but it doesn't. So maybe if I rebuild, it should do it. That's so weird. It should check it. Hey, I'm not that far along. I only have like, what is it? Four streams before this. It's only like a couple of hours of work before this. And also I'm doing it in not the most optimal way. Basically, I struggled through the API documentation first, but if you're gonna use OpenGL, it's gonna be a lot quicker. So we got this all set up now. We do have our render API header file, this one, which is, oh, I copied the correct, no, I copied the CPP file, damn it. Okay, let's spin this. Yeah, okay. And then you don't use C++? Well, doing it with C is a lot harder. F12, this one. Okay, so we're gonna copy this, put it in this one. That should all set up. HP render, we're gonna call it DX12 window, and we're gonna, basically you can't do this in C. You can't have classes, which makes it a lot harder. HP render window. So we're gonna include that, right? Hey, I don't need that. This we want to get rid of. I would suggest actually doing it in C++. Actually, yes, I think C++ is the easiest one to do it in. I mean, there's a discussion to be made about Rust, but I don't know enough about Rust to tell you about it, basically. We don't want this to be in there either. We're gonna have to make like a create function for the window. Naming variables sometimes, I mean, yes. Programmers are known for making shitty names. I mean, there is something like a bit and a byte, right? And that's just a byte is basically 8 bits. But then they also have a name for 4 bits, and they just called it a nibble because it's a small byte. I mean, naming is not the greatest thing in programming. They just try what they get rid of. Okay, so now we need to make our API. So this is gonna be hard to figure out, because basically where's my U? We're also gonna pin U. Basically, we need to do all of this, right, which is all the Windows stuff, but we can't pass this. So that's gonna be a bit tricky. I'm not sure how to do that yet. What is Pragma in my code? Okay, so there is something. So basically, an include that is standardized in the standard CPP library, in the CPP code, that has an exact implementation of like, this is how it's supposed to work. Everything else, class, public, all the keywords, they all have as an exact implementation of how they're supposed to work. Pragma are things that are not standardized. So that's technically compiler specific. In this case, I'm using MSVC, which is the Microsoft compiler. So they might handle it differently than a separate compiler like Clang or GNU or whatever. So this is not standardized, this is standardized. What it does, this Pragma once, it's called an include guard, which prevents files from being included more than once. You can learn more about that, but basically it prevents you from having loops in your code where you go like, I include file A and I have a file A, and file A I can include file B, and then in file B I include file A again, you just go round and round and round in circles, and this pragma once just prevents that, saying like, hey, I already encountered this file, I'm not gonna include it again. Now, the pragma once is like kind of the exception to the whole thing. Basically, it's as good as standard at this point. Everybody uses it, but technically it's not correct standard CPP code. And you should actually do something like an include guard, which is if not defined this, then define it. And that's basically how we used to do it back in the good old days. And then at the end, you of course need to end it. But it's, I mean, this is so bad, so annoying, so big. So everybody implemented pragma once. Everybody might have done it slightly different, but on every single compiler it works. So this is standard now, even though it's not standard. Kind of the exception. And then pragma warning, same thing. We're disabling just some compiler specific stuff. It's, well, in this case it's compiler warnings, so we're disabling specific ones, but depending on which compiler, the warning numbers might be different. That's why it's a pragma. Okay, that was a lot of talking. But yeah, that's basically it. So I need to know how to get, well, I need to get rid of all of this, but I don't have these, right? These are passed from the main function, basically. The H instance, I mean, this is gonna be so annoying to do. Because basically, if you go back to our main file, what we do here is we pass the winproc, which is just a pointer to a function, with this specific, like, thingamajig. That is so specific, so it might be that we need to put this. Although, basically, I mean, we need to get rid of the Windows thing, right? So we're gonna have to make like a Windows wrapper at some point as well to hide all of this, to hide all the window creation code. That's basically what we're doing. So technically we can basically put it separately, but I don't want to do that because I know this Windows procedure will also handle like messages and stuff, and I want to do this in a somewhere. I basically want to do this somewhere else than here. Right, this is gonna be like our game loop. So that's bad. So we need to get rid of this. I don't know how yet. So we're gonna have to make like a message loop. It's gonna be bad. It's gonna be bad. Okay, and then we also have the H instance, which we get from the win main function. So this will, I mean, this will need to create like a, okay, no, it's fine. We're just gonna have to specify it's gonna be a DX12 window here. I think for now that's fine. We will get rid of it later. We clean this up later, but for now I think we're not gonna do this though. We can't do this because this will need to be generalized. Oh wait, no, we can. Never mind, we can. But we're gonna have to also call the normal window. Okay, I get it. I've got a plan in my head now. Good. You had a question. What is a render API? Well, so we draw things to the screen, right? Render API is in charge of all of that. It's in charge of making the full window. It's in charge of saying like, hey, I want to draw a triangle at that position. Triangle appears there. So we're just gonna make like a call to the render API saying like add triangle at this position, and the render API will do its magic and the triangle will appear on the screen. Basically what we have now. But I'm doing it in a bad way. I'm doing it in a not structurally way. I don't have the function add triangle yet, for example. Not that we will ever have it, but different discussion. Oh, that's what I'm gonna be working on. Okay, so what do we need to do? Well, first of all, we need to get set this baby up, and we do want the window title in here. These are specifically for something else, so we can't have those. This is also fine. We show the get handle, other issues, but we can't store this in here. And the window title, can we store it? Do we actually need the window title? What do we need it for? Oh, it's to create it, isn't it? Okay, but I think that's actually fine to store in here. So this is just... Oh, we'll need an implementation for this now. Oh no. Yeah. Okay, I need to make another file now. Which will be... Yeah, makes sense. Yes, okay. We need to make another file now, which is in render API. We're gonna copy paste this. And it's gonna be .cpp. Okay, yes. And we need to include it in our render API CMake. It's gonna be here. Duplicate this CPP. Okay. But again, this one I don't want to make one for. I mean, questions are fine. Don't worry about it, Kiri. Especially if you want to learn. I have nothing against all the questions. Okay, let me first find back what I actually need to do, which is rebuild zero check again. Okay, so rebuild. Basically, private and public. For C code, I don't think you need to worry about it. For C++, we have a concept of a class, right? That's the things I'm making. And what you have is you always have a public API and a private API. The public API, everybody that has an instance to that class can use. Private is purely internal data, internal functions, things that anything outside of the class actually doesn't have access to. So if I go to, I think the render API is a good example. Where's the render API? So what do we have here? We have a bunch of public functions. This is going to be the functions that we actually call on the object to do things, like initialize or load asserts or the load assets or render. These are all public. Anybody can call them if they make a render API object. Private, only the class can use. Nobody else has access to this except the render API. So the render API can use this for whatever it wants. Nobody else can access them. And that's also why we keep always the members private, because nobody else can touch these. You need to work with the public API with all of these functions to access it. That was a quick overview. It gets more complicated because you have protected, which is for inheritance. But that's, I mean, basic concept first, right? Okay, I built it. It's correct. It's filled in. So now we need to. Okay, we need to get rid of this. This we don't know. We don't need. Great, perfect. Okay, get handle. We're also not gonna put on this one. Show. I don't know what's in here actually. Show window. Yes, that's fine. We're just gonna make it abstracts. Can't. Oh, it's not virtual. Yeah, that makes sense. Window height. Okay, and then we're gonna put. Yeah, it's basically exactly the same as in Java. At least the concepts are the same as in Java. You also have public, protected, private, and all of those things. And that's, yeah, object-oriented programming. So, const jar window title, we're also going to store that here. Yes. Technically, we want to get rid of this. But that's fine. We can store it in there and then do that. Why there's some weird curls in my triangle? It's actually, believe it or not, how do I explain it? Basically, I made a shader where each point of the triangle has a color assigned, and I needed to make sure that all the pixels get calculated correctly. So that's why you see like the gradient in the triangle. It's basically my shader, the thing that actually colors the triangle doing its job correctly. I could make it a single color as well. I could make it even more complicated if I wanted to, but this was just a basic example, and it's generally like the basic start. It's basically the hello world of a graphics program. So we include windows.h here, and then we're gonna do render window, no, not show window. There we go, and then this is gonna be an empty one, and inside here we're gonna say m.window width. Why is it doing that? That's so bad. So it's GLSL shaders. DX12 uses GLSL shaders, shader language to compile and run everything on the GPU. Window width is width. So I'm not writing my own shader language. I'm gonna use GLSL. Yes. Window height is height, and then the window title is the window title. There we go. Basic. We got this. Why is it? Oh yeah, I need to static cast these to a float because I want to worry about width and height. Okay, so there we go. Copy this. It's height. I mean, GLSL is basically industry standard at this point. And since it's only like a concept, it's basically another programming language, so it's allowed. Not making my own programming language. Okay, good. This works. We got a window. DX12 window. You see some books in the background? Wait, which? Where? Oh, yeah, so those are all my programming books. Hidden in the corner. These are the fun ones. These are the manga I have. There's not that many, but I mean, it's a small, very small collection. It's only like 10 of them or something, but yeah. Window. Okay, so we got this. We got all of that set up. That's perfectly fine. This is all fine. So we're gonna go to the implementation here, and then why is this? Oh, we need to include DX12 window. This one. Right. And then this would be the DX12 window. Put this in here, and then we're gonna do not this, but window title, width and height. There we go. I live in Belgium. And yeah, hi from Ninja. Okay. Set up this thing. This is all still fine. Show window handle. Why don't I store the window handle? Oh wait, wrong one. DX12 window. Show. That works. Boom, boom, boom. Done. This is all correct now. This works. This should also work. We'll fix the issues in a second because I think. Oh no, we still got the setup here, so that's all fine. I think it's actually up to, it's done now. I do want to predefine this though, but we can't because we need to get handle. Oh yeah, the get handle function will be annoying in a bit. Yes, famous for chocolates. Couple other things as well. So we need to make a DX12 window. That's bad. We still need to get rid of this, but issues for another time. Initialize the window, so we're gonna have to do with a pointer, apparently. So actually it's better that way. So we're gonna do it with a pointer. And then I think the render API will still complain because we have get handle here. Hello, welcome to the stream. Making a game engine. Working on the render API today, so the things that actually draw it on the screen. or actually making it. Basically, taking what I had, which was a lot of library dependent code, and hiding the fact that we actually use a library. So that later on, if I want to swap libraries, make another, like go from DirectX to OpenGL or to Vulkan or to whatever, I just need to replace a small part of the code, but all the rest will still work. And it's going, but it's going slow. Okay, so this get handle function doesn't work anymore, which was expected, but what we could do, and I'm gonna do it here, even though it's a bit iffy, is we're gonna say DirectX12 window pointer DirectX12 window equals, is it dynamic cost? It's dynamic cost. To a DirectX12, oops, window pointer, and what I'm going to dynamic cost is of course the M window. And why does that not work? What do you mean window is not polymorphic? It is! Fascinating to see somebody write code like this nowadays. Okay. That works. I don't know why it's complaining about the dynamic cost though. It is polymorphic. Or can I just do a static cost? Might just be able to do a static cost. Oops. There we go. Good luck, thank you very much, I'll need it. Yes. I think this is correct now, and we could actually build? I might have issues. We have issues. Show peer specific only allowed on a virtual function. Yeah, makes sense. Yes, where's my thing? So it's gonna be virtual show override. There we go. And then this one should be virtual. That's one issue fixed. I don't know what the other was, I didn't read it. The structure is not virtual, it's gonna say. I forgot about that. Virtual. Oh, and we should mark US final. There we go. That makes sense. And then let's also put US virtual for now. We don't need to, but it's fine. Any other issues? There might be. There is. Static cost. Inaccessible. Conversion from that to that exists, but it's inaccessible. Why is it inaccessible? That's weird. Let's see. This is all fine. Why is... This shouldn't be in there. This should also not be in there. This should be just virtual. This should be just override. That's correct. This should also not be virtual. That's also correct. Should be override. Save. Build solution. Gonna work? No. Exist but is inaccessible. That makes no sense. We include it here, which is correct. And then in here, we include the correct one, don't we? Yes. Also, you should be in there. That works. Let's also just put it at the top here. Why does it not work? It's been a while since I did object-oriented programming, so let's find a static cost. Oh, Yeah, a stupid mistake. I forgot. Inheritance is basically always private, so we need to say it's public, and then we can change between the types. Build. Does it work? Almost. Initialize can upwork argument from that to that. Makes sense. So in here we need to pass it the pointer. There we go. Boom. You do program as well. More learning about AI and machine learning. Makes sense with the state of the industry. Makes sense. I'm lucky enough to be able to still be able to program C++ the old-fashioned way. Okay, triangle, still there. Boom, done. Still the same as it was before, of course. That's great. How long have I been okay. That's that. So now, we kind of made a DX12 window. We obfuscated the DX12, so our actual generic API for a window has no longer anything. Why is this complaining? This should be complaining. Private field not used. Yeah, shut up. Actually, that makes sense. Why is it? If you don't need it in here, I'm just gonna do this. Do const char pointer. And get title. And then put the window title in here. There we go. Now it is used. And then where's the DX12 window? And then in here, we actually don't do that, but we do get window title. Twice, apparently. Okay, yeah. Perfect. Done. Build solution. The name of my game engine, I mean, it's not really anything deterministic at this point. I mean, it can change at the moment. At the moment, I'm calling it homebrew because I'm making it at home. Makes sense, right? So it's homebrew engine, which is also why I have all the HP and the HP underscore things. Stands for homebrew. It could change. I do like the name though. Makes a lot of sense. Basically making a game at home, so. And I am having fun. That's correct. That is definitely correct. I do love programming. And I had like a Rust developer, or let's call him a Rust enthusiast, watching the stream last week. Constantly convincing me, trying to convince me to switch to Rust. It was very funny to tell him no. And every single time it's like, why? Switch! But, I mean, I'm having fun, that's true, that's the important part. Although, most of the fun comes from struggling for 3 hours and then figuring it out last minute. So, I mean, that's called fun in my eyes. Okay, it still works. So, yeah. Window check. I'm not thinking about any stream implementations like that. Yeah. Okay. This is basically our window. We have a title, a width, and a height, and the implementation is hidden away. Why did I make the CPP file again? Oh yeah, to just have the constructor. Ah, that's fine. Yeah, sure. That is fine. And then we have a virtual one here. Makes sense, right? Okay, done. Bosh window, done. I still don't like that we have to include windows here. But it's because of this. So stupid. Technically, I mean, that is a reference, right? Oh, but we store it by point. We store it by that. Oh, it's so annoying. Wait, Windows annoying, so annoying. let's actually see if we can have like a Windows type thing, so we don't have to include all of Windows. Windows. That's 23, 32. H window. No, I just want the documentation for this. There we go. Windows data access types. No, just give me the file where they're in. WinDev. Maybe we can try that one. If that's the case, we don't have to include all of Windows. Oh no, we need it. Okay, never mind. No, I said nothing. We need it for the WinProc and the H instance. That's fine. Aha. Done. Okay. It's gotten rid of. Technically, we still need to. Can we pimple it? We can't pimple it. No, it's all fine. I mean, it's not pretty still. I still want to get rid of like the WinProc and the H instance, but that's a different issue. I need to sleep on that. I don't see an easy way to get rid of it. But that's the window done. So now we can focus on the render API maybe. Where's render API? So we got this, which has still a bunch of stuff in here that I don't want in there. We got rid of this. So we got our window. Do we need anything else? All of these things, I'm also gonna be like, nah, it's gonna be annoying. We need to hide all of this. How did I get into game stuff? Valkyrie, played a lot of games growing up. Asked myself, how are they made? Started to learn how to program at 12. Started with C++. Big mistake. Gave up after like 2 months. Well, that's not true, but I still was interested, but I understood that I couldn't do it. So I tried some other things. Eventually I got like a C++ course in class, like in my last year of, what's it called? Middle school? Was hooked from the start. And then decided to continue following it. Did engineering after that. Just kept making like small little games on the side. Eventually enrolled into a game dev course. Here we are. Making a game engine. Somehow. Okay. I'm gonna stop with the render API stuff for a second because I want to focus. I mean, there's two things mainly I want to add. Well, two things. At least one thing I want to add to the code and the code base. Yeah, two things. There's two things. And to do that, we need to add another project. I think I already have it set up actually. So we have like the engine core. It's not what I want. The core lib. We have a core lib. Inside here, we're gonna make a new file. And we're gonna call it asserts.h. Oh yeah, I did a lot of stuff. Don't worry, my channel is not that new. I've been like on and off producing videos and streaming for a long time. Okay, so we're gonna make an asserts, and we're gonna make what's it called? How do we gonna call it? Like defines. Macros. Defines. Yeah. Does that make sense? Yes. Okay, so we got those two files. Do I need to set up anything? I don't think so. I shouldn't have closed that. Oh, okay, well, fine. This, and then that's that. Okay. Core lib. I don't have CMake yet. Oh, yeah, no. Homebrew. We're gonna add a subdirectory engine, and then under engine. I don't have that file. Inside here, let's open this one, and then we're gonna add subdirectory core lib. There we go. And then we're also gonna link core lib in there. And I'm gonna already set up that render API also links with core lib. So we're also gonna set core lib in here. that makes sense. There we go. That's that. And then we are gonna have to rebuild again. Rebuild selected parts. I want a shortcut for that. Okay. Which is non-existing. Why is this non-existing now? Did I mess something up in the CMake files? So we did core lib, which is fine. Engine. Add subdirectory core lib, add subdirectory this. Oh, core lib and render face, that's fine. Core lib. I don't know if core lib has a CPP, a CMake yet. It does. Is there anything in it? Ah! Yeah, this is wrong. That should be, let's copy the render API one. Set sources. So in this sources we have asserts and defines, and that's it. And then we're also gonna do a render API dot add library. Yeah, and set properties folder, that's also in there, but it doesn't work unfortunately. There, and then we're gonna call it core lib. Okay, and then we can build. Oh, I was hoping it would work. Did I mistype asserts? Oh, I made it assert. Okay, asserts. That makes more sense. Yes, go to sleep. Thanks for stopping by. Thanks for all the questions. Hope you found it interesting, and hope to see you maybe next week. I'm doing this all week, so whenever. Oh, there's no CPP file in here. Okay, CPP. Thanks. Yeah, have a good night, Kiri. Thanks for stopping by. And then we're also gonna make a CPP file from this, because we need a CPP file to link stuff, unfortunately. But I think we're gonna have to use this anyway, kind of. Okay. And then let's do, come on, rebuild. Okay, we got a core library now. What we're gonna put in here, we're gonna put asserts in here and defines in here. Let's start with the defines. The defines is pretty easy. Basically, I have like this render API file, right? Where is it? This. And we got like this. We're gonna have to do that like a lot of times for a lot of classes. So what I'm gonna do is I'm gonna make a macro for it. So defines, we're gonna do define delete copy and delete move, and then we're gonna do class name, and then we're gonna do this, and then we're gonna do backward slash here, backward slash here, backward slash here. Oh, and I need to do pragma once, of course. Pragma once. So include guard in there. We have a delete copy and a default move. And then we're gonna do a delete copy and delete move. And what this is gonna do is it's gonna allow us to still adhere to the rule of, what is it now, 7, 8, 9? I don't know anymore. Basically we can do this, and then inside our render API we can do this, and then call render API on this. All time there. And then we included that, right? Include defines, yes. and include the window as well. Okay, so we have this defined now, which means that we can, well, this basically expands to all of those functions we had before, and I think it's a lot cleaner of doing it. I also gonna remove this semicolon for the only reason that now it will not compile unless we put a semicolon there, which is great. I like that. I like that change. We're also gonna make it kind of the same one again, but with a default copy, delete copy and a default move. Default move, right? And then we're gonna do the move to default, and this move as well to default. And then we're gonna make one last one. You guessed it, with both of them as default. It does not make sense most of the time to have a default copy and a delete move, because a move is always better. So this will be just all the default ones. There we go. And then I think you can also do that for this. No, wait, that's a delete copy and delete move. Delete copy and delete move. And then we can do X unique pointer. There we go. Done. So much cleaner, right? I love this. Okay, so I got it for that. Do we need it for the window? Window doesn't have any. It will probably say like, hey, you don't have it to shine. I don't care. If you don't have it specified, it's just normal. Yeah, that was the first thing I wanted to do. Basically that. Actually, I want maybe already make another. No, you're not gonna make. I just explained that we don't implement anything that we don't need. But yeah, this perfectly fine. Asserts. We're gonna make a runtime assert now. So pragma right, and then we're gonna make another define. That's an assert, and the assert is gonna be an HP assert, right? And it's gonna be condition message. And then we are gonna do some weird stuff. Basically, we have static asserts, but we can also do this, and I don't remember how to do it actually. Hold on, because we can do like if condition, if not condition. So if we don't succeed our condition, then we're gonna do this. Then we're gonna print out the message, right? So we're gonna have to include IOStream, which actually I don't want to do here. So we're gonna make, hold on. Let's let me think about this for once. So basically, hold on. I wrote this before already. So I'm just gonna take a quick peek at that one and see if we can just yoink it. But I do think we have like, yeah, I had a CPP as well. So how did I do it? Oh, like that. Okay, makes sense. Yes, that makes a lot of sense. Okay, I think I'm still gonna do it like that. And then I'm pretty sure we do that, and then yes, that makes sense. But we don't have any code configuration now yet. Okay, that makes sense. So what we're also gonna do is we're gonna make, if not condition, that's all fine. We're gonna make a struct here, which is HP private HP core. No, we're just gonna call it HP assert. HP underscore 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 private. So nobody will include it. Assert. And that will have our message. Right. And I'm gonna, again, forget the semicolon, which will do that. Then we're gonna make a namespace, which is HP in here. And then we're gonna do private, sorry, HP private. And this is basically, this is the best hack. Well, best practice to do in basically programming. This way, this is something so useful. I mean, you should have this in your code base. Gonna make a struct assert, right? And the only thing that's gonna be in here is an assert message. There we go, perfectly fine, right? And then we're gonna have to go to the include. This is in the CPP file. We're gonna do assert. All we're gonna do in here is we're gonna see out the message. Never do endline. It's slower. Always just put a backslash in there. Good tips. We got IO stream. I don't need mode stream. Right? I'll put out a message, and we can actually also put a breakpoint when this happens. Right? So, with all of this, which is really cool, we can go to main. We can, let's just put a runtime assert here. So let's do HP assert. And then we're gonna say false, so it'll always trigger. And we'll say, look, assert. And we're gonna put one before it, which is true. Will never trigger. And what this will do is if we compile this now, I hope it builds. It might not, might have something. What the hell is this error? In limits, one secure lib is not defined as a preprocessor macro, replacing with 0 for if else. What? What does that even mean? I mean, it's gonna be in the assert one, so it's probably gonna be here somewhere. What is this? I've never seen this in my life. A symbol that was not defined was used in a preprocessing macro. The symbol will define a symbol you can use. Oh, Q is not defined. But that's the whole point. We define this. It's probably complaining about this. What? But that's the... The symbol was not defined, was used in a preprocessor directive. Okay. Okay. Fine. I don't want that warning. Ever. I think. Because we want to check this with if-def, right? Yeah, this is all fine. Okay. So... Okay, where's my CMake Homebrew, you, and then CMake compiler options. Does it find it? No, it doesn't. Damn it. Also, shouldn't it be CMake? I think it should be CMake. There we go. Right, so we still need this. Oh, it's so annoying it doesn't find that. Where's my... Okay, where's the... Q. Okay, CMake. Compiler options, right? Gonna add another warning, which was... you. That I do want to disable that in debug and release, and then let's see what this one. There we go, and that's also for false positives reason. Okay, makes sense. Good, done. Push. Build. I need to rebuild. I need to make it automatic. That would be so much more useful. Build. There we go. It's compiling. It's compiling. It did everything. It took 4 seconds already. That's quite long. Okay. So now if we run, we should get... We skip the first breakpoint, but we get to the second one, right? So if we check the stack... Where's the stack? Here. We are right at this assert. The first one succeeded. If we check the console, nothing yet. Oh, debugger output, no. Console. And if we continue with one step, which is you, it should print out somewhere. I don't know which where. That it should print that message out. I don't know where it is though. Is this the console? No, it's a terminal. Okay, let's just continue. And then somewhere in the console it should have said it. Thought I wasn't here. Okay, let's try and remove the debug breakpoint. See if that fixes it. There we go. It's not in this one. Huh. Where's the output window? Either that or it might not be enabled. How different is the JetBrains IDE from, say, something like Vim and Clang? I mean, conceptually it's probably the same. It's just how you navigate that's differently, I guess. I mean, with every single IDE, is it Visual Studio, is it JetBrains, is it Vim, you still need to set up the build system how you want it. So for the JetBrains IDE, it's basically the same as for a Visual Studio solution. I've never worked with Vim or Clang D, so I wouldn't know how different it is. I do know Vim is like notoriously either you like it or you don't like it. I've not tried it. Don't think I will at this point. Not pretty sure how different it is. Okay, so I think what's happening is we don't have an output stream bounds to the console. Which is fine, although I do want it to actually show you. So I need to find out how to print to the console. Win32 print to console. This is peak programming right here. I mean, this is gonna be something basic, but I mean, I don't, if not use it. And your console operator main function has to be main. That's all fine. That's not what I asked. What the hell? So, wait. See out. How can I tried to use whether a command prompt, but it doesn't work. I tried searching product console application. With the parent calling console window in a Windows app, I only want this behavior if parent is 0 or past, so it's not common. It doesn't have a console window attached by default. When a GPU is run from a console process, the UI app can attach, or if they sells you console window, it can create its own console. Ooh! So you might be able to do this. Okay. Interesting. Oh, wait, no. Print to debug console. I need to know this. Oh, it's output debug string. Of course it's output debug string. Oh, you idiot. I knew this. Oh, okay, so we don't do this, we do output debug string. Oh no, we're not. Oh my god, okay. Where is output debug string actually? Debug string function. It is in debug API. Include Windows API. Oh no, I don't want to do this again. Oh, fine. Right. And then where is the Windows 32? Oh, was that window? It wasn't window, right? Yeah, it wasn't window. No, that's the DX12 window. Oh, yeah, and this one. Copy this, and then inside our certs. Again, we need to get rid of this. To do get rid. We need to get rid of that as soon as possible. Output debug string, and then it takes a pointer to a string. So let's yoink that to that. And then do std. Well, this is gonna be all of the things. String. Formatted message. We need to include string as well. New, and then std format. And format is gonna be assert. this is gonna be the message. \n. There we go, and then message. There we go, and then we're gonna put that in there. Dots up. Let's see string. There we go. That should all work. Build solution. It's gonna. What? Stop and build. Okay, it's built. We can debug it now, and we should see things in the console. Console. Still nothing. Huh. Interesting. Output console. Nope. Jump over. Oh, we're in a weird spot. Let's just continue and see if anything got printed to any of the consoles. No. What is happening? Output debug strings definitely go do it to the debugger outputs. But this is the graphics debugger. Ha. I mean, it does have the exception at least, but why is it not outputting the console, the output debug string to the window? Hold on. So, does not have debug, and the filter masks allows it. The system make it displays a string. Can we check if the debugger is there? And this one, right? I'm confused. I thought it was gonna be like an easy addition. Every single time I think it's gonna be like super simple. Not printing. It might be because I'm running in release. Let's check. So if I run it in... Oh no, I'm running in debug. Why can't I see? What? This is so confusing. Why does it not work? Oh, great. That's... Enable native code debugging. Huh. I'm at a loss here for a second. What the? In order to view output, try selecting the enable native code debugging project properties debug tab. Might it have to do with my flags? Maybe I'm missing a debug flag or something? I don't 100% know. I mean, output debug string should definitely work. So let's see if we can get rid of these two. Wait, not these two, these two. Oops. Okay, just don't then. Thanks. There we go. You got that. It probably doesn't compile now because some flags might be missing. Okay, it does, so we're gonna just rebuild that first, please. Apparently that does work. Okay. Good solution. And if we run it now, do we get in the console? We don't get the message. I mean, you should be knowing. You should. I mean, output debug string did nothing. Is it like another window? View, window, build, debug, console. Is it like output? I don't see an output. Edit configurations. What is this? Oh, I'm so confused. Why is it not? What the? I mean, release maybe? Build. Warning of running OP2 with OP3. F2 and 3. Yeah, that's fine actually. So does it print it and release? Probably not even. Yeah, it's optimized it way even further. Huh? I'm a little bit much confused. Alright, so let's see. Let's put a rider in here and see if there is an issue with a rider. So let's check the debug settings, I guess. Let's stop this. Debugger settings. Let's see if we can do it with an external console, maybe. Okay. Where's the external console? Continue. There's no console anywhere. I'm so confused. Terminal. No, it's just a lot of terminals. Sample application. Yeah, but where's the debug window? Where's the... I'm like 100% sure we can definitely just... Huh? Okay, I'm so confused. Run configurations. Let's get rid of this again. Right. Platform that launch profile local. What the hell? Focus window. Huh. I'm so weird. What is... Output debug strings sense. We can check for is debugger present. Okay, so let's just call that quickly. And that should be true. And we can check that in an assert actually, so let's do that pretty quickly. I'm losing a bit of... No debugger? Question mark? We'll see pretty quickly if that's the issue. So let's oh, we're in... Okay, let's do it unoptimized. Because otherwise I won't see a thing. It's building, it's building, it's building. Yeah. It will do that and it will assert. And where does it assert? Look, no assert. So there is a debugger attached. So we need to find out where the debugger output is. Okay, so we can do this. True, but no output. Oh, does output debug have a error code? What the hell is going on? Titanic. Okay, let's see. Let's see if we can do a get lost error in this. Get lost error. Do we need to pass it something? No, it gives us int the word. Well, no, what? The word error equals. Okay. Okay. Yeah, I know it's not used. If error has error. Let's just maybe unused it. Maybe unused. I'm debugging. It's fine. This. Compile it, run it, ship it. Error is 0, so it did print it, but why is it not showing? Might it be because of the... Hold on. Render API? Where's render API? You might be because of this? Is it the final release? No, it's not. I'm confused. I'm so confused. Because this is like, we have a console here. Writer Win32 app not outputting to console. I'm confused. I am confusion. Right, it doesn't show up with the debug console window. There we go. That was not helpful. What am I missing? Do I need to put C++ in here as well? I think I'm gonna give up for today. I am not getting anywhere with this. It's so weird. Basically, I just want an assert. And I got the output debit string, which is the correct one. It should put it in this console, but it's not doing it. So let's give it like one last attempt, right? Let's do Uh-oh. There we go. Let's do a writer debug output LLDB. I don't. Is that even the right name? Debugger output LLDB. Yes. Let's find out what LLDB stands for actually. Okay, so Win32 log to LLDB. Oh, that was bad. I think you're looking for output. I am using output debug string. It's not showing it. Uh-oh. There's an open issue. You can't tell me it's a fucking issue. It's been an issue. Okay, so can we do writer msvc debugger? Probably not, right? They made a pull request for it and everything. It's still open. What's the status? Huh. Oh my god. It's just not supported in the debugger yet. Oh, and I'm going crazy over here. Okay, so we need to find another way to log it. Oh my god, that's gonna be so annoying. So, does not work yet. Does not work with the debugger. That's so annoying, but that's a good point to leave off. Man, I wanted to get this working. Ugh. Oh well. Because now to actually get it working, we have to start our own console, our own debug console, and print messages there, which is so stupid. I don't get it. That's so annoying. What? Okay. Output debug strings to work. I can probably open this. I'll test this off stream, but I can probably open this in Visual Studio and it will work perfectly fine. It's either way, it's fine. Okay, good. Yes, that's it. I think we can just get rid of this. Just believe me, it works. We don't need any of this. Going this. We don't need any of that. We can build the solution again. Right. Oh, I want to get rid of that as well. That's a stupid warning. So that's a good last thing to do. Let's find out what the O2 flag does. I'm supposed to say. That's fine. What does O2 do? O2 is all of these. So let's copy all of these, right? And then let's put them inside our compiler options. So we got all of that. So all of these, right? And we're gonna get rid of this. We're gonna substitute that for O3. And we need to add all of these. Oh god, that's gonna be so annoying. That is gonna be very annoying. The more aggressive inlining is nice to have though. I know that for a fact. So we're gonna leave it and just do yoink. No, let's just do O2 and let's fine. Yeah, it's fine for now, I would say. We can live with that. We're working in debug anyway. Debug is not slow enough for us to worry about it yet. We can come back to this when we actually need to. Okay, so still triangle. Still got a triangle on the screen, but we're getting closer to a better API. I mean, the progress has been a lot slower than I was expecting, mainly because well, the Windows API and both the DirectX API are kicking my ass, and then apparently Rider is also not pretty decent. I mean, the debugger is not. That doesn't have output debug string. Why can I not output things to the debugger? I mean, it's used so often, and I don't get it. Either way, it's in progress. It's fine. There is an issue for it. It's created. I can check back in it with like a week or two. And it should work. Or I just use my own for. Yeah, it's fine. Okay. So still got a triangle. API is getting there. We already obfuscated some of the DirectX and Windows calls for the window. Next week will be render API. I need to read up on what all the things we need are, and we still need to figure out a way to get the update loop correctly working. So that's a lot of interesting things for me to worry about. I might also do maybe a little bit of programming. I'm not sure. Probably I'll just say that now and I will forget about it. So nope. But anyway, Good stream. I had a lot of fun on this one. Still the same exact results. It just takes time. And yeah, I think that's about it. We can end off here, and then we'll pick it up next week, right where we left off, working on the render API. And that's about it. So let me find the button to enter stream again. Oh, there it is. And yeah, I'll see all of you next week, where we continue tackling this game engine project. And I do want to continue working on it. I don't want to keep working on the architecture, but it is early stages, so we need to set it up properly. That will make it all way easier in the end. I think it will be worth it in the end. But yeah, for now, I'll see all of you later, and yeah, have a fun rest of your day, and I'll see you next week. Bye. I missed the button. Okay, there we go. Bye.